Okay, so I'm going to go through a review of Unit 10. So to start, we're asked to identify whether each of the dilations is an enlargement or a reduction, and we're given the scale factor. So the main key to remembering how, or knowing how to do, not remembering, this type of problem is to know that k greater than 1 gives you an enlargement, but k less than 1 gives you a reduction. So really, these questions, all I need to know is which ones are greater than 1 and which ones are less than 1. So 3 over 2 is greater than 1, enlargement. 2 over 3 is less than 1, which is a reduction. K equals 1.3 is an enlargement, greater than 1. K equals 0.5 is less than 1, which is a reduction. And then on numbers 5 and 6, we're looking to see, again, if it's an enlargement or a reduction, and this time to find a scale factor. So you may have multiple choice options here. I would ask you to just ignore the options and to solve it without them. So we're going from A, B, C, D, E to A prime, B prime, C prime, D prime, E prime. So we start at the green shape and then go to the pinkish red shape. So it's definitely getting smaller, which we would term reduction. And then to find the scale factor of our reduction, we need to figure out what do I multiply these points of my original image, so these green points, what do I multiply them by to get to my red points? So I would just pick one, so I'll say pick the x value of my b point, which is 3, and then I have to multiply that by the scale factor, and it ends up equaling 1. So to get k by itself, I would divide by 3 on both sides, and k is equal to 1/3. And then if I look at number 6, I'm going from this ABC triangle to this A prime, B prime, C prime triangle. It's definitely getting bigger, so this time it's an enlargement. And then to find my k, I'm going to do the same thing. So I'll look, say, at this point, and it's at 2 on the y-axis. And then I've got to multiply that by my scale factor to get to 8. So 2 times what is equal to 8? Well, most people can pretty clearly see that that's 4, but if not, you can just divide by 2 on both sides, and 8 divided by 2 is 4. On numbers 7 and 8, we're just given 1 point and how it changes instead of being given the pictures. So from 0,6 to 0,4, well, that's definitely getting smaller, so that's going to be a reduction. And then to find my k, I could try and take my 0. 0 times k is going to equal 0, but that's not very helpful because this could be literally any number. So I'm going to use my other two numbers. So 6 times k is equal to 4. And then to get k by itself, I divide by 6 on both sides. And 4 over 6 is equal to 2 over 3. So my k is 2 over 3. And then on number 8, my points are getting bigger, so this is an enlargement. And what do I multiply 2 4 by to get to 4 8? Well, most people are like 2, but if you don't know, you could set up 2 times the scale factor equals 4, divide by 2 on both sides, and 4 divided by 2 is 2. And then number 9 is just a review of our similarity tests and theorems. So there's 3 different similarity tests and theorems. The first, and order doesn't necessarily matter, is angle-angle. The second is side, side, side. And the last is side, angle, side. Awesome. So then, leading from that, we're now going to decide if pairs of triangles are similar. So my first pair of triangles, in order to know if they're similar, I need to know what this third angle is. So if I do 180 and subtract 60 and subtract 81, I'm left with 39 degrees. And then 180 minus 40 minus 81 is 59 degrees. So if I look at these two triangles, they don't have at least two angles the same, they don't have three proportional sides, and they don't have side angle side, so I would say no, not similar. And in that case, I wouldn't even have to fill this part out. On number 11, I have a side angle side, and the angles are the same. So if my sides are proportional, then I could use side angle side to say that they're similar. So we need to check the sides. So if I put 12 over 8, and I get 15 over 10, and if I divide each of those, this divides to 1.5, and this divides to 1.5, and since those two are the same, that means that they're proportional, so yes, these are similar. And then I just have to make sure that I put my similarity statement in the correct order. So I started at A over here with the 40-degree angle, which is D here. And then I moved over the longer side to B, so over the longer side to E, and then F. 12, 13, and 14, we're going to go ahead and graph some translations and dilations. Number 12, I think, is probably the easiest because you can actually just count it. If I'm moving right 3 and down 2, I'm just going to take each point and go right 3, down 2. And so this is T prime. And then I'll take my Q, right 3, down 2. This is my Q prime. Take my Y, right 3, down 2. This is Y prime. Take my M, right 3, down 2. This is my M prime. And then I can go ahead and just connect my shape. And I have a translation that's moved right 3, down 2. When rotating 180 degrees, I find it easier to list my points. So W is at -4, 2. E is at 0, 3, and G is at -4, 0. And then when I graph my translated points, all that needs to happen is the signs switch. So instead of -4, 2, I have a +4 and a -2. Instead of 0, 3, I have 0, -3, and instead of -4, 0, I have a +4, 0. I'm going to go ahead and graph that. So I have 4 and -2. So this is W prime. And then I have 0, -3 is E prime. And then I have 4, 0, which is G prime. And if I go ahead and connect these points, I have a triangle that's been rotated 180 degrees. 14 is a dilation. So again, I think it's easier to list the points. So I have L is at 1, 5, D is at 0, 2, and W is at 5, 4. Now dilation, you just need to multiply by your scale factor. So when I find my L prime, I'll do 1 times 1/2, which is 0.5, and 5 times 1/2, which is 2.5. And then D prime is 0 times 1/2, which is 0, 2 times 1/2, which is 1. W prime is 5 times 1/2, which is 2.5, and 4 times 1/2, which is 2. And then I can go ahead and just graph these points. So I have 0.5 and 2.5, which is about right here. 0, 1 is here. And then 2.5, 2 is here. And then if I go ahead and label those points, then I can connect them, and I have a dilation of 1/2. Number 15, I have a tree. So I'm going to draw a tree that casts a 12-foot shadow. So this is 12 feet. And then nearby there's a 6-foot sign that casts a 3-foot shadow. What is the height of the tree? So I can go ahead and set up a proportion to solve this. So I have H, and then the corresponding line on this side is 6 equals 12. Corresponding line on this side is 3. And then I'm going to go ahead and cross multiply. So 3 times H is 3H. 6 times 12 is 72. And then to get the height, I can just divide by 3. So my 3's cancel. And 72 divided by 3 is 24. So my height is equal to 24 feet, which makes sense because 3 times 4 is 12, 6 times 4 is 24. So it keeps our similarity going.